Welcome back. On this video, we're going to talk about how to do the second project in our Fusion Manufacturing Milling series. This one's going to touch on a few things, including drilling, probing, and 2D chamfering. So let's hop right into it. Okay, to get started, we're going to go ahead and first save this, and we're going to call it FMM-2 setup 1 and our last name. And I'm going to save it into my key folder where I have all my files saved for examples. Now, the first step we need to do is we need to bring in the table and the vise and the work holding into Fusion. So we're going to go back to our machine work holding library, which all my students should have access to. And we're going to go to milling. And for this one, we're going to use the same mini mill setup, vise number 1. So right click, insert into current design. And we need to go ahead and make sure that the Z-axis matches here and here, and go ahead and click OK. And then in order to work with it, we're going to have to break the link. So we're going to go ahead and hit break link. Now, if we look back over at the drawing, we can see here's the part size. It is essentially a little bit smaller than 2 by 2 by 0.6 or 600 thou. This would actually lend well to making it out of 2-inch stock that's 3/4 of an inch thick or 750 thou, and then cut it to 2 inches. But we're drilling through it, and frankly, we don't have that stock on hand. We hold a lot of 2-inch by 1-inch aluminum stock, so that's what we're going to make it out of. So we're going to go back over here, and the first thing we're going to do is modify the stock. So we're going to go to modify, change parameters. And we're going to change this to 2 inches in depth, which it already is, 1 inch high, and it's 2 inches wide. And click OK. Now this has the stock in the center of the vise. Perfect. Next thing we're going to do is we're going to go get the file that we need and bring it in. So mine's down here in my master teacher catalog. And here is FMM2. Right click, insert into current design. And there it is. And I'm going to slide it out of the way temporarily so we can properly join it together. Now we're going to assemble it. So we're going to go to assembly joint. And we're going to select the center of this. It does not matter top or bottom because once again, this part is symmetrical. And we're going to select the top there. And it brings it around, not in the way we want. We want to flip it around so it's inside the stock. And then we want to move it south 20 thousandths. I always like to move it manually the way I want it. And then I can come over here and be like, okay, negative 20 thou. And if we look at it from the front, we can see that there's a little bit of room left for us to machine it away. We're going to go back here. And now we have the file set up in Fusion, ready to go into manufacturing. Okay, we've moved over to the manufacturing tab here, and we're going to go ahead and start with our setup. And our setup here is selecting the whole part. So we're going to start by selecting which machine we're going to use. For these first few projects, we're sticking with our mini mill. So I'm going to go to the local. I'm going to select mini mill and hit select. And then it is a milling operation, which we don't need to change. We're going to come back to work coordinate system in a minute. We're going to go to model. And to do that, we're going to go ahead and open model here, open it again, and select the FMM2 for our part. And then for our fixture, we're also going to open 1 and select everything but the stock. I'm holding down Shift on the keyboard, and it selects it all. Now, we're going to go back here to the box point because on Op 1, we wanted to cut always at the top. So we are going to go and make sure that we are on top center. Now, our mini mill has a probe. So we're going to actually use the probe to find the workpiece before we machine it. And when we do that, you typically want to make the center point of the material the center point of your project where your work coordinate system is. You use corners when you typically have to manually set up projects, but this is the best approach when you have an electronic probe, which we have and we're going to use. Okay, so this first tab is all done. We're going to go to stock. We're going to select from solid. and then we are going to select the stock over here, which is perfect. We're going to position our work table on the machine. And the easiest way to do that is we're going to find the two corners. We're going to go select point, and we are going to select this point of our table. And then this point is the one that matches the best when we select it. The tables are obviously slightly different. And there is our table in line with their table. And lastly, we're going to go to this project page, and this is 201 for project, or 2 is for the second class, 01 is the first set of projects, and then this is project number 1, and it is, this is project number 2, and this is setup number 1. There we go. And we're going to reiterate that kind of information down here by FMM-2, setup 1, and your last name. And then for the work coordinate system number, we use G55 and G56 to make our first part. We're now working on the second part, so we're going to use G57 and G58. So we're going to change this to G57. And we're going to go ahead and click OK. Now our setup is all done. We can minimize this just to make more room. I'm just going to click anywhere to kind of hide the machine temporarily. And we're going to go ahead and get started with our manufacturing processes and do all our operations. So the first operation is when we put this piece into the machine, we would have to orient it in the machine. Basically let the machine know exactly where the piece is. There's lots of ways to do this, but we're going to let the machine find the piece using a probing operation. So to do that, we're going to go ahead and go to Inspect, and we are going to go to Probing WCS. We have to select our probing tool, which by clicking here and then going to the tool library, we have a Renishaw probe in tool slot 10. So we're going to go ahead and select that using the mini mill. And then it's going to ask us, we're going to skip multi-axis, and we're going to go to geometry, and we are going to select the 4 sides of the stock. Notice the stock has not been hidden yet. We need this for the probing, and then we'll turn it off. You see the tool pass for the probing operation. The probe will come down. It's going to find all 4 sides and orient itself in the center. And the advantage to this is if you put the probe in, the part in, and you don't get it perfectly centered in the vise, the probe will compensate for that. We do have to change the positioning a little bit. We're going to increase this to 0.1. That means if you're off, you can be off by about 0.1 from the center, which is actually a very large margin. We don't need to make any adjustments in height and or action, so we go ahead and click OK. Now, just like we did with our first project, our first operation after this is facing, we need to switch back to milling here, and we're going to click on facing. And our tool is the 3-inch face mill, so we're going to go back into the tool library, select the 3-inch Mitsubishi face mill, make sure we're cutting in aluminum, and hit select. There's nothing in multi-axis. Geometry, it automatically selects. We're not changing the height. We're not changing the passes. We're not changing the linking parameters. So we go ahead and just click OK. And you'll notice that it'll produce a nice cut for facing. The next step, just like FMM-1, we are going to do an adaptive clear to remove most of the material, and then we're going to do a finished contour so we end up at the perfect part. So we're going to do adaptive clearing. Our tool is the 3/8 standard end mill we use. So in the student library, 3/8, make sure we're selecting aluminum and hit select. Now, to get in and get the geometry can be quite hard. This is where we need to hide the stock. So we're going to unhide this. We're going to turn off the stock and then rehide it so it's out of our way. And now I can go in here and select the ring around the outside. Like before, we want to push the cutter a little bit south so that it'll cut a little bit more. So when we do the flip, we'll get a nice clean part. And we are going to do an offset of negative 20 thou, not 200 thou. And then under passes, we need to also turn off stock to leave in the axial because we just told it to go 20 thou too deep. This one's telling it to come 20 thou back up. It basically means nothing's going to happen. So we're going to hit 0 here. Now it will push 20 thou too deep. There is no linking parameters that needs to be changed, and we click OK. And if we zoom in, we can see that there is a small gap between the bottom of the part and our cut line. Now, next step, repeat this process except for in a contour so we can cut it to finish size. So click contour, it's going to remember the tool, skip multi-axis, go to geometry, select the same ring, go to heights. We are going to still push it negative 20 thou deep. Oops, I shouldn't have hit enter. I went to edit, right click edit to get here, and then there is no change to passes and there is no change to linking parameters, so we can go ahead and hit enter or OK. Okay, those things were all mostly other than the probing repeats from FMM-1. The new stuff we're covering today is drilling. We need to drill these 4 holes. So we're going to click on drilling. These holes, if we look here, are 201 thou in diameter, which happens to be a number 7 drill bit, a very common drill bit because it's also used to make a 1/4-20 tap, which we'll talk about in a future video. So we're going to come over here and we're going to hit drill. When I went away from it, it went away. And I need to select a tool. And not shockingly, in the tool library I provided for you, tool number 8 happens to be a number 7 drill bit, which is 201 thou in diameter. So we're going to select that, make sure it's in aluminum. We're going to go to the second tab, geometry. Now we can select each hole individually, which is no big deal for 4 holes. But if we had 400 holes, we could also use select same diameter, and it will find every hole on the part in this orientation that is that diameter. So we now have the diameter, or we have all the holes selected, I'm sorry. Now we're going to go to heights. The problem with heights is if we look at it from straight on, the very tip of the cutter stops at the bottom. When we flip this over for the second setup, we want to make sure these holes go all the way through. So we are going to do what's called drill tip through bottom, which will push the cutter through the bottom. But this also could produce some problems, especially if the angle of the drill bit doesn't match exactly the angle that you programmed in Fusion. So what we're actually going to also do is add a little bit, and we're going to add another 20 thou just to make sure we get all the way through. Now, under cycles, there are options for how we drill. Now, this is not very deep relative to the diameter. So drilling, a lot of it has to do with how big is the diameter of the hole and how deep it is. And when you get kind of beyond 5 times D, which means take the diameter of the hole, 201,000, multiply that by 5. When you're starting to get that deep, you need to start doing other operations like full retract, where the drill bit will go down a little bit, come all the way out, then go down a little bit more, come all the way out. Or partial retract, where it'll go in, come out just a little bit, and go back in. That'll break the chip and help you clear chips out of the hole. For us, this is only 3 times the diameter deep, actually just slightly more. So we're well within the parameters that our cutter should be able to make, so we don't need to change anything here. Now for linking parameters, there's nothing we're going to change, and we're going ahead and click OK. It's going to take a moment, and it's going to lay out the 3 drilling holes. There we go. Now, the last step is if you look at the drawing, it says chamfer these edges. Notice there is no chamfer modeled on the part. Now, we can put a chamfer on in the manufacturing workspace, or we could model it in the design workspace. The problem is when you model it in the design workspace, you have to approach it differently than if it's not modeled. So we're showing you how to do it without modeled. Later, we'll have an example where it is modeled, and we'll show you how to do it when there's already a modeled chamfer. So what we're going to do when there's no chamfer modeled, but the print is calling for chamfer, we are going to go to 2D chamfer. We are going to select our chamfer tool. Now for this one, we do need to change it to aluminum 6061. And we're going to go ahead and click OK. And then we are going to go to geometry and select this top edge. Now, because this is a chamfer tool, under passes, it says we're going to do a chamfer. So we're going to do a width, according to the print, is 0.035 or 35 thou chamfer, which I've put in. Now, tip offset, the chamfer is V-shaped like this. The chamfer's tip is very, very weak. So the offset moves it over and down a little bit more so that when you cut the corner, you're cutting in the stronger part of the cutter. We only need to be concerned in that this is going to offset at 40 thou. Remember, we have a 1/4 inch cutter, which is 250 thou. Divide that in half. We have 125 thou, and then we move over 40 thou. We still have 80, 75, 80 thou left in material plus the 30. Take that, then take away 35 thou. We have plenty of space. If we were doing a really big chamfer like 100 thou, then we would have to be a little bit more cautious. That would also show up in the simulation, just so you know. And we're going to go ahead. There's no linking parameters change, and we're going to click OK. And you can see it's putting this blue line around, and it's knocking off the corner ever so slightly. We're now ready to simulate. We're going to go ahead and click here and click simulate. You'll notice that we got no issues when we went through the simulation. We're going to go ahead and hit play, and the probe is going to come first. It's going to probe the part to find where the center is. Now it's got the center, and we're going to do facing. I'm going to accelerate this ever so slightly. We're going to do the adaptive clear and then the finish contour. We're going to drill the 4 holes, and then we are going to put the chamfer around the outside edge, and we can zoom in and see that we have the first side of our Fusion Manufacturing milling done. Our final step is to post-process it. Click post. Remember to make sure that this is the Haas Next Gen Control. We are going to paste our name in the file name so it comes up easier on the flash drive at the simulator. We are going to make sure it's going to the downloads folder here, making sure we're using Go or G0 is what it actually reads. And in the built-ins, this should be at 450, which if you did it correctly in the first one, you'll be fine. Then hit post. I'm going to get over here really quickly and hit this. Remember, you're going to get a window. You're going to pick select Notepad, and then you can see the code all right here. And the big one is you can see here that it's going to rewrite the work offset for G57 after it probes. That concludes FMM-2 setup number 1. For my students, please take this code and we're going to run it through the simulators in the front of the room. For the rest of you, hopefully, well, for all of you, I hope you learned something, and I'll catch you in the next one.